In this video we're going to take a look at the Log4j vulnerability, and we're going to do that through the TryHackMe room which John Hammond created. I was actually going to make a video on one of the Advent for Cyber challenges which TryHackMe have been running this month, because I haven't done any videos on TryHackMe before. In fact, my first room completed was John Hammond's Log4j, so this came out just about at the right time. I did actually try to make a video on it on Monday, but ran into a couple of issues which I just decided I would leave it a couple of days and come back to it. So we'll have a look at that. I have already been through the machine, but let's go through it step by step anyway. So just before we jump into the text that we have here, we've got a machine that we need to start. So we can start a machine here. This will run for 1 hour, although we can extend the time. And we can either connect to it through VPN or use the attack box, which is like a web-based virtual machine that you can access. I'm going to do it through the VPN, which will mean that we have to install a couple of libraries and stuff rather than doing it in the web-based VM. But I did actually have some problems with the web-based VM the other day as well, so I'll describe those when we get into them. To connect to the VPN, I'm going to run VPN and then TryHackMe, because I've already got a bash alias set up which will just make the connection for me. Oh, nearly connected to the wrong one. Nearly connected to the wrong one again. There we go. Alright, so we connect to that. Let's make sure we get an IP address. Yep, we can see that we've got our ton0 here, so this is our IP address for TryHackMe, which means we'll be able to communicate with other devices, other machines on the network, including this Log4j VM that we just booted up. So it takes a minute for the IP address to show, but let's go and have a look through some of the text that we have here. So we're told here that on December 9th, 2021, the new vulnerability was identified, Log4j or CVE-2021-44228, affecting the login package. It was given a severity score of 10, which is the most critical, and it allows trivial remote code execution on hosts which use the Log4j version. The attack has been dubbed Log4Shell. You can now use 2.16.0, which will patch the vulnerability, so JNDI is fully disabled, support for message lookups is removed, and new denial of service vulnerability is not present. So there's a link to that which we can have a look at, go and download and patch your systems. And then this just tells us that due to how widely used this package is, millions of applications are going to be vulnerable. There's going to be a lot of dependencies to it, and they've likened the vulnerability to shellshock due to the nature of its enormous attack surface. We'll see this vulnerability for years to come. There's a list which you can go to here, Log4j attack service, which will tell you which services have been identified as vulnerable and which are not, or which have been verified there. And we also have some articles here we can take a look at. Here's one, I guess probably is by the company that John works for, so I'm sure he had a hand in this article as well. And he also made a video going through setting up Minecraft and exploiting it on Minecraft, which is where this vulnerability arose from or was discovered in, but obviously it'll affect any applications that are using the Log4j. A very good video, definitely check that out. And then we've got a note from the author. Please use this to improve security, basically, don't be malicious, etc, etc. And bear in mind that developers of the Log4j package work on open source projects, so they're basically not to blame. There's like 2 or 3 employees who work for this unpaid, and that's quite often the case when it comes to vulnerabilities like this. If you think back to Heartbleed, which I think had 1 full-time developer, and he pushed a patch at like 1 minute to midnight on New Year's Eve or something, which had the vulnerability in it. So obviously they can get the blame for things like this, but at the end of the day, if you have big corporations and large applications which are making use of these open source packages and they're not diverting some of their funds into helping the developers, you've got to kind of question who's really to blame for that. Alright, so we've been through our first section, which was called Introduction, and we don't need to answer any questions here, so we're just going to hit completed. Completed. Oh, we got the correct answer, awesome. And let's go on to the task 2, which is Reconnaissance. Okay, so we're told that we've been given this virtual machine and it has the Log4j package in it, allowing us to explore the vulnerability. We've been given the IP address here, and we're told to run nmap against it, a basic nmap scan. So I'm just going to take a copy of this and paste this into the terminal. This is just a basic nmap scan running with verbose mode, so that anytime a port is discovered, it'll come back and give us that port straight away. We don't have to wait till the end of the scan to see which ports are open. But it's not doing anything else. It's not doing a service enumeration or running any scripts or anything like that. And it actually, did it miss a port? Let me see here. Okay, we only ran the top 1000 ports there, so let's run this again, and let's say we want to do all ports, all 65k ports, and we should come back with what looks like it's going to be 8983 as our port then. Let's see what we need to hit complete on here. We'll hit complete here, and we need to give the name of the software on port 8983. Alright, so it's still not even found that to be open yet. Let's take a copy of this address, and let's do nmap-sv for services, and then ports 8983, paste in that address. Let's just get that moving while we're waiting for this one as well. Okay, so that came back with Apache Solar, so let's take a copy of that. As we can see, the room name was Solar as well, and we'll submit that. We've got our correct answer, so let's move on to the next stage of discovery. And for discovery, we've got some files to download. We've got the task files here. Let me see, I don't think we can wget that, so I'm going to open this up, and okay, let me create a new directory called logs, and let's go and paste these in here. Just so we've got that ready, let's go and have a look through some of the text here. Alright, so it's running Apache Solar 8.11.0, one example of software known to be vulnerable. And for the sake of showcasing the vulnerability, the application runs on Java 1.8.0.181. We're told to explore the web interface available at this URL, so let's go and take a look at that. And get a feel around for the application. For more details, please visit the official website. This instance is provisioned with no data whatsoever. It's a flat, vanilla, absolutely minimum installation, and yet at its core is still vulnerable to this CVE. Okay, so we go and log in here. We're in this dashboard. We can see some configuration settings here. We can go into login. Doesn't look like we can do too much here. Security, core admin, Java properties, where we have some more of our configuration by the looks of it, and thread dump. Okay, had a quick look around. Let's go back and see what it's actually asking us for. Take a close look at the first page visible. You should see some clear indicators that Log4j is in use within the application for logging activity. What is the dsolar.log directory set to? Dsolar log directory is this one here, var solar logs. So we'll take a copy of that, paste that in here, and we've got another question correct. Download the attached files. Okay, so we've got the files, explore each file, get a feel for what's in there. Let's do that first of all then. Go into logs. I'm just going to open up Codium with, if we just provide a dot here, it'll open this up as a directory. And then we can just kind of flick through the logs that we have here. Okay, so we've got our request log, which is empty. We've got our console log, I guess starting the application. You can see some versioning, stuff like that here. And then we actually have our logs here, so we've got 3 different logs. I don't like how whenever it gives a 0.1, 0.2, we don't get any syntax highlighting. But yeah, we can go and have a look through the log. We can see our various requests which are being logged here. Path admin, params are empty, status 0, queue time 0. Okay, let's go back and see what it's actually asking us for here then. So we've had a look around, got a feel for what's displayed in the log. One file has a significant number of info entries. Which file includes the repeated entry? Alright, well what we could just do here is go Control and F and then search here. We can see that we've got 104 matches on this log. We've got 36 matches here. We've got 26, we've got 12, we've got 0 and 0. Alright, so it's obviously this one with 104, which is our solar.log. So we'll just enter that here, submit that, and another question correct. What is the path or URL endpoint is indicated in these repeated entries? That was the admin part, right? Path admin. Oh, path admin cause. The line wrap nearly got me. Alright, we submit that. And viewing these log entries, what field name indicates some data entry point that as a user you could control? So back here we have the params, which are currently set as empty. That looks like something which a user would be able to control, the parameters. Let's say params. And we've got another one correct. Alright, good stuff. So that's the discovery out of the way. Let's move on to proof of concept. And we're told here that the URL endpoint needs to be prefaced with a Solar prefix, so let's take a copy of that URL and we can visit that, and we notice the params seem to be included in the log file. You might be beginning to see the attack vector. The log4j package adds extra logic by parsing entries, ultimately to enrich the data, but may additionally take actions and even evaluate code based off the entry data. That's the gist of this CVE. Other syntax might in fact be executed just as it is entered into log files. Some examples of the syntax are, and then we've got some example payloads here which we could use to recover some data. You may already know the general payload to abuse the log4j vulnerability. The format of the usual syntax takes advantage and looks like so. So we have this JNDI, which is the Java naming and directory interface, and then here we've got an LDAP URL with an attacker controlled host. So in this case we would be able to provide an LDAP server that we control, and then from there have a secondary payload which would launch. As it says here, this indicates the target will reach out to an endpoint, an attacker controlled location in the case of this attack, via the LDAP protocol. I'm not going to cover all the details here. Okay, I believe there are other protocols that can be used as well. For now, know that the target will in fact make a connection to the external location, our attacker controlled host, and you as an attacker in this scenario can host a simple listener just to view the connection and make sure the attack is working. So that would be a way to probe this vulnerability and try and identify whether services are vulnerable. You don't need to try and actually exploit them, but you could just see if they can make a callback to a HTTP server that you're running. The next question is, where can we enter the syntax? Anywhere that data is logged by the application. This is the crux of the vulnerability, unfortunately. It is very hard to determine where the attack surface is for different applications, and what applications are in fact vulnerable. Seeing the presence of log4j files doesn't clue in the exact version number or even how the application might use the package. Think back to the previous task. You already discovered you could supply params to the Solar admin cores URL, and now that you have a better understanding of how log4j works, you could understand this is where you need to supply your inject syntax. You can simply supply the HTTP get variables or parameters, which will then be processed and parsed by log4j. All this takes is a single line of text and makes the vulnerability extremely easy to exploit. Other locations you might supply this JNDI syntax could be username and passwords forms, data entry points, or HTTP headers such as the user agent and x_for, or any place for user supplied data. And then we also have a link to some slides from a Black Hat presentation from 2016 where this attack vector was presented. I did see some tweets about people kind of saying that this attack vector was known and kind of having a go at the developers for this. At the end of the day, most attack vectors are well known and old. Look at SQL injection, cross-site scripting. Every time we see an attack, well, we do kind of say, why is this still happening? But at the same time, it's not like this was specifically identified in the package, in the log4j package in this presentation. Okay, so with that out of the way, some background on this, let's see if we can do some of the practical side of things. It's telling us to identify our IP address, which we can do that just with ifconfig or IP address show, as we can see here. We want to set up a netcat listener. Alright, let's go and do that. So we'll do netcat listener NLVP 9999 or any port of your choosing. Oh, we need to hit complete here as well. Complete. And then we're given a command here with a JNDI payload syntax, as we can see here. So we're going to make a connection out to this service here. And you can see here it's basically taken in as a parameter whatever malicious payload. So the payload is going to go here, and that's going to go into the log and then hopefully be executed. Alright, so I'm going to take a copy of this. You can see here it's just noting as well, using the $. If you use double quotes here, you're going to have some problems. And if you don't escape that, you're going to have some problems as well. Oh, let me keep that open so I can see what's going on in the background. Okay, and let me just end this scan. Didn't realize that was still running. Okay, need to go and update some of this. So what's our attacker IP address? Just going to delete this. Let's do ifconfig again. Take a copy of our address. We'll paste that in there, and then we'll try and make a connection. You'll see here we got a connection back. We've got some funny looking characters. We can't actually type anything here. It's not like a shell, although if you're used to doing hack the box, well, I suppose TryHackMe as well. If you're used to doing kind of vulnerable machines where you would be getting reverse shells. This is a similar kind of message that you would see, but without this stuff after. Okay, what did it ask us for here? No answer needed. Alright, good stuff. Connection received. Okay, also good. Okay, so that's the proof of concept out of the way. Onto the best part, which is exploitation. And it says, at this point, you have verified the target is in fact vulnerable by seeing this connection caught in your netcat listener. However, it made an LDAP request, so all your netcat listener may have seen was some non-printable characters, which were the strange looking bytes that we saw here. And we can now build upon this foundation to respond with a real LDAP handler. We will utilize an open source public utility to stage an LDAP referral server, and this will be used to essentially redirect the initial request of the victim to another location where you can host a secondary payload that will ultimately run the code on the target. So it breaks down like so. So we're going to send this as a payload, and it's going to reach out to our LDAP referral server that we're about to set up, and we're going to provide the URL here. And then the LDAP referral server is going to act as a springboard to a secondary HTTP server, which will have some kind of malicious resource on it, and the victim's going to retrieve and execute that resource from us. So we need to set up a HTTP server. It's given us an example how to do that. We can do Python 3-m HTTP server. We can also do, if you're using Python 2, it's Python 2-m simple HTTP server and then the port number. I have an alias set up for this, a bash alias, so I'm just going to do web up, and that's just the same as me doing Python 3-m http.server port 80. And so I'm doing that port 80 instead of port 8000, so if you're doing this yourself and trying to work through it, you'll just bear in mind the port might be different. You can also do this with the attack box, and here's a video to show how to do some of that. Okay, so that's that done. What else do we need? Did it tell us to download something else there? No. Okay. Complete. First order of business is to get the Marshall Sec utility, which will allow us to set up an LDAP referral server. Okay, so I'm going to open up that link. Ultimately, it needs to run Java. I suggest using Java 8. You may have success using a different version, but to play by the rules, we will match the same version of Java on the target machine. Okay, so this is the problem I ran into when I tried to do this video on Monday, and in trying to set this up, it tells us to go and download this Java 1.8. Let me take a copy of this. Let's open up this mirror. Let's do Control and F, and this is what it's telling us to download. So if I go and do copy link, and then wget, and let's see how quickly this goes. So I started running through this the other day, and you can see here ETA 6 hours. I think my ETA went up to like several days. So instead I opted for trying out the the attack box. But with the attack box, whenever running another one of these commands down here, the Maven command, the clean packages, it ran into some problems. It just kept hanging on a certain step. Alright, so that didn't work out. I figured I would come back, and I expected that in a couple of days we would be downloading this Java package a lot quicker, but that's not the case. So what I did is I just went and downloaded it from another mirror, and I'm going to copy it from my downloads folder. So copy downloads, we'll copy that here, and that's just the exact same file that we were told to download. And then we need to go and set this up, so I'm just going to copy and paste a few of these lines. So we'll just, we're not going to need to make that directory because that directory already exists. So instead we'll just cd into that directory, and I'm going to move our desktop TryHackMe logs JDK. I'm going to move that here. Okay, let me do sudo tar xzvf, and then that should be fine. So we're just basically unpacking this file. No, that wasn't fine. Without the dot, okay, because I was trying to move it to begin with. Alright, so that's going to unpack our JDK in our user lib jvm. And then now we need to just basically say that this is what we want to use. I'm not going to do all this manually or type them out one by one, so I'm just going to copy and paste that, run that, and then let's try and do java-version and just verify that we're using 1.8.0, this 181, which is what we've just downloaded and installed. I should have really run Java version before doing that, just to show that I wasn't already using this version, but oh well, that's done. Let's move on to the next step. We also need the Marshall Sec. Okay, so let's go and download this as well. I'm going to go back to desktop, and let's git clone. This tells us here how we can run this, and we're basically just going to do this as is here, but I'm going to go and copy and paste it from TryHackMe because they've got the full command already set out for us. It's telling us how to do this if we're using the attack box. Here's the steps to download this manually if we want to do that. We also need to do sudo apt-get install maven so that we're able to build this, so let's do that as well. And then here is our command to build the marshal-sec utility. So let's go into marshal-sec, let's run that. Hopefully we won't run into any errors. Let's hit complete on all this stuff. And then this is the command that's telling us to run here, which is just what we saw here, but with everything filled in, all the file names and things like that. And this is what we're gonna run. Well, let me go back here, let's paste this in. And let's go and update our addresses. So I'm not using port 8000, I'm using port 80, so I don't need to specify a port, as that's the default HTTP port. And let me run ifconfig again, because I don't know what the IP is. Paste that in. Alright, just so we're ready to go. And let's go back. No, let's go back and see, is this finished? It has finished. Build success. That's what we like to see. And let's try and run this other command then. Alright, so it's listening. So this is basically just set up a listener on our LDAP server. So this is running like a fake LDAP server basically. Whenever it receives a connection, it's going to make a referral to this IP and this exploit file. This is the resource that we're interested in. But that means we need to go and create the resource as well. So let's go and see what the next step is. What is the output of this command? Listening on. Submit that. Okay, that's it. And now that it's ready and waiting, we can open a second terminal, prepare our final payload. Ultimately, Log4j will execute arbitrary code that you craft with a Java programming language. Okay, so we're basically going to take this code to make a shell. Let's open this up in Codium. Exploit.java. Make sure you get the file name right here. I had this with a lowercase e the other day, and it needs to match Java needs to match the actual class name that you have inside the file. So just bear that in mind. Oh, zoomed in way too much. And let's grab the IP address again. I should really just keep ifconfig open. Take a copy of that. Let's paste this in here. That's fine. We can leave the port as it is, 99999. That's what we've got our netcat listener on at the moment. And yeah, all this is doing is it's basically saying whenever the log4j parses the log, it's going to see our. Let me go back to where we actually have this. It's going to see a referral to this LDAP server, which we've got set up. The LDAP server is going to send it to our HTTP server with an exploit on it. And then the exploit that it's actually going to execute is going to be this exec, and it's just going to call netcat to set up a reverse shell, basically, to connect to the reverse shell. That should be everything. We need to build this file. Let me go back down. Compile your payload with, okay, let's do that. We compile the payload and okay, just completed. Python HTTP server, I think we've still got one running, but I'll go and check in a second. Netcat listener, I think we've still got one running as well. And then this is going to be our exploit. Run the above command and catch a reverse shell. Okay, so onto the actual exploitation. I've got way too many windows open here. Let's see what we've got. And close that one. Let's set up this netcat listener again. I'm going to close down that one. Close that one. Alright, so we've got a netcat listener waiting for a reverse shell. We've got a HTTP server waiting to serve our exploit. We've got an LDAP server waiting to receive the connection from the victim. And we're going to paste in this curl address. We need to go and update our IP address, which I'm going to take from, okay, that's a link. I'm going to do ifconfig again. And yeah, let's paste that in here. Let's try and run it. We've got a response from the curl, and let's go and have a look here. We can see we got a result here redirecting, so it's received a connection to the LDAP server and it's redirecting to our HTTP server to grab this exploit.class. You can see on our HTTP server it tried to grab that and it's actually got file not found. Okay, so did I not compile that properly or something? Okay. Notice that the HTTP server is in logs and we have our exploit.class in Marshall sec, I'm going to assume. Yeah, okay. So I'm going to run the web server again there. Let's just do the same thing again. Run this curl. Oh, where did it go? Alright, I'm going to copy and paste it again. Copy and paste that. Let's check this again. Alright, so it made the connection to the LDAP server. It's redirected to our local HTTP server, which has now successfully served up the exploit.class with our reverse shell in it. And then our netcat listener has received a connection from, and then we can basically check and see who am I with Solar. We can run various commands as we've now got a shell into the system. Okay, so that's great. Let's see what's next. Go and hit completed. We'll go and hit completed again. Well, let's have a little read through. So it's basically just saying at this point now we've got a full shell, so you could do anything now. You could install cryptocurrency miner, you could use some ransomware, or you could just use your shell to snoop around and grab some files. All this took was a string of text, a little bit of a setup which is freely available, and obviously this awesome room which was put together for us by John, because I probably wouldn't have bothered to set up much of a demo without it. Some troubleshooting information here. If you do run into any problems, you can go through that. And after receiving a reverse shell, feel free to experiment. Okay, complete. I'm not going to go through much experimentation. Let's just go through the room as is. Wow, there was a lot of steps in this part. Alright, so that's the exploitation done. Let's have a look at persistence. And it tells us, now that we've gained a reverse shell, we can continue, take any action we might like. We're going to grant ourselves better access to explore the machine, analyze affected logs, and even mitigate the vulnerability. You may have noticed that port 22 was open for SSH. Now we could add private keys, or we could add our authorized key, so that we can then SSH in, or we could change passwords. And whenever we run who am I, what do we get? Well, that's the first thing that we ran, and we found out we were Solar. It's telling us here if we want to stabilize our shell, we can run some of these commands. Okay, so this is very handy. Basically, at the moment, if we go and try and type something in here and then do, well, if we do tabs, we don't have autocomplete, and if we try and use like our character keys here, it's not going to give us what we want. So we can use this. We can import pty, spawn bin bash. You can see that's already looking a bit better. But what we also want to do then is do Control and Z, SSTY raw -echo. Oh, STTY, sorry. Wondering what went wrong there. And then we can do FG, and then we can export term equals xterm, and now we can run clear, and we've basically got full commands here. We can see we can do autocomplete. If I do ls, or if I type something in, I can use my keys and stuff like that. Alright, so we've upgraded our shell. Okay, we don't have bash aliases though, that's fine. Let's see what else it asks us for. Complete. We can check our permissions with sudo-l. And it's telling us we can run all commands as root. Okay, complete. Complete. It's telling us we can SSH in here. I'm not going to bother to do that unless we really need to, because we've already got a decent enough shell. But you can go through that if you so choose. And we're on to task 7, which is detection. Okay, so this stage tells us that finding applications vulnerable to this vulnerability is hard. Detecting exploitation might be even harder considering the unlimited amount of potential bypasses. That being said, there are some tools and scripts and stuff like that which have been put together by the security community, and we've got a list of some that might help here, so you can go and check some of these out. I'm not going to check each one individually, but we've got a listing of some vulnerable jars and class hashes. We've got yeah, seems to be mostly what we're dealing with here. Hashes of vulnerable jar files and class files. And we've got some Yara rules as well. And as a reminder, we've got a massive resource available here. Let's have a look. Which has got some more links to details. Okay, so all that looks good. I'm not going to go through it on the video here, but let's move our way through. The questions that were asked here, it says to explore our own logs, use SSH connection or our reverse shell to move into a directory where the Solar logs are stored. You already know what this path is, as you gave it as an answer in task 3. Okay, so presumably I think it was var log, which would make sense. But if we go there, we don't actually, let me have a look, it might just be in var. Yep, cd Solar, okay, and then cd logs. And there we go. Alright, so I'm just going to take a copy of this, var Solar logs. Oh, no answer needed. Okay, complete. Review the log file. Okay, let's see what we've got here. Cats solar.log. Zoom out here. It's probably not going to look very pretty for you, but it's to get things on one line, it looks a bit better. You can see here we have our params, which are supplied, and you can see right here we have our param, which has JNDI, LDAP, and then IP address and the port 999. And then just down below that we have another one which has our exploit in it as well. Okay, terminal too small. Let's continue and see what's next. Did it ask us for something? No. Complete. If you'd like to experiment more, try some of the bypasses in the task below. Okay, so detection complete. Let's have a look at the bypasses. So the payload we've looked at is the standard and typical syntax. If your penetration test are a red teamer, this syntax might be caught by web application firewalls or easily detected. If you're a blue teamer or incident responder, you should be actively hunting for and detecting that syntax. Because the attack leverages Log4j, the payload can ultimately access all of the same expansion, substitution, and templating tricks that the package makes available. This means that a threat actor could use all sorts of tricks to hide, mask, or obfuscate the payload. With that in mind, there are honestly an unlimited number of bypasses to sneak in the syntax. We're not going to dive into them all, but here's some examples. So, various bypasses here. I'm sure a lot more will be discovered as time goes on. I saw from somebody on Twitter that if you send a request to the HTTP server missing out this curly brace at the end, that it will return basically everything after from the server. I haven't really looked into that, just saw it on Twitter, so maybe somebody can let me know a bit more about that, or go and have a explore. Notice the RMI protocol used in the last one. Okay, so that's what I was saying earlier. It's not just the LDAP server that can be used to serve up the exploit. Additionally, with the Log4j engine, you can expand arbitrary environment variables, if this wasn't already bad enough. Consider the damage that could be done even with remote code execution, but with a simple LDAP connection and exfiltration of an AWS secret access key. For other techniques, we strongly recommend you do your own research. There's a significant number. Okay, and then we've got that link again. We're told to use this knowledge for good, of course. And read the above and remind yourself you're a security professional with a strong moral compass. Alright, yeah, love it. Okay, and on to mitigation. So now that you've acted as an adversary for a bit, please take off your hacker hat and let's mitigate this vulnerability on the vulnerable machine. Review the mitigation techniques suggested on. Okay, let's go and take a look. So we can see we've got some CVE reports here, so we can see the various CVEs which have been registered for Apache Solar. And mitigations, any of the following are enough to prevent this vulnerability. So we can upgrade. If you're using the official Docker image, you don't need to worry about it. You can manually update the version. You can edit your solar.in.sh file to include the following, or you can follow any other mitigations listed here. Alright, so yeah, plenty of stuff there. I'll not go through it all again, just as long as you know where to access this stuff. And we're told here to determine where is this file, the solar.in.sh, because that was one of the options there, was to manually modify this. So we'll locate that and we'll find where it is. Does it ask us for the path? It does. Submit. Okay, and then it's telling us we can basically go and add this line. So I'm going to do vim. I just copied that instead. Alright, vim default solar.in.sh. Oh, this is read only. Let's quit and let's do sudo. I'm just going to insert this randomly here. And then we'll save that. And there we go. That's done. Save, close the file, completed. And in order for that to take effect, we need to restart the service. So we'll do that as well. It's running through restarting, complete. And to validate the patch has taken place, start another netcat listener as you've done before. Spin up your temporary LDAP server and the HTTP server, again in separate terminals, and then basically try to re-exploit the machine and verify that we have indeed fixed it. Okay, so let's do that then. I'm going to close down this terminal. I'm going to just restart our HTTP server. Oh god. Sudo kill all -9 Python. There we go. Okay, I'm gonna stop that and start that as well. Oh god. Kill it all. You can see my my method of restarting programs is very legit. Okay, that's that done. We need to launch our netcat server again, nc-nlvp9999, and we want to make this same request again, and hopefully this time it's not going to work. There we go. You see, we didn't get a hit on our LDAP server. We didn't get a hit on our HTTP server because our LDAP server didn't get a hit, and therefore we didn't get a shell. So we've actually just patched this vulnerability without patching the version. Brilliant. Alright, so done. Alright, so we've mitigated the vulnerability. Mitigation done. Next is patching. So at the time of creating this exercise, 8.11.1 has not been released with a formal patch. Alongside many other software providers, the industry is frantically scrambling to patch their software and push it downstream to end users as quickly as they can. Please be understanding of this frenzy. There are so many potential places for this Log4j vulnerability could be present, and we may never see the end of this vulnerability for a long time. The onus is on you, on me, on every single one of us to raise awareness of this incident and hold the community accountable for actively responding. When the time comes, roll out the patches that have been made available and continue to hunt for instances of this vulnerability. It takes a village. And then, where appropriate, please ensure you patch login Log4j package to 2.16.0 or higher. And in this new version, JNDI is fully disabled, support for message lookups is removed, and the new DOS vulnerability is not present. Download this release here. And then we're told to answer the question below. I understand the implications of this and will patch early, often, and always. Complete. Great, so that's our 10 tasks done. We've got task 11. Credit and author's notes. Thank you for clicking all the way to the end. I sincerely hope that you read these parting words. Okay, I better not skip them then. This exercise is brought to you with a wholehearted intent that it improves your awareness, learning, and understanding of this vulnerability for the right reasons. The material presented to you could not have been possible without the incredible contributions from security researchers, incident responders, system administrators, and security practitioners all around the industry. We owe an incredible thank you to the professionals all working sleepless nights around the clock for going the weekend and fun time with friends and family to better protect the internet. While Hollywood hacking is cool and flashy, cybersecurity is a team sport. Please review the external resources and make this community a better place. Awesome. So that's it, my first TryHackMe machine done, although I did actually do it already, I just came back to record it. So all in all, a great room. I'm glad this could be my first room completed on TryHackMe. And TryHackMe in general I think is a great platform. It's very different to Hack the Box, which I'm used to. But I do like the kind of mix of questions and theory here, you know, because Hack the Box really just forces you to go and Google things and try harder, as they say. But this is a great format as well. I'll definitely try and check out some more TryHackMe in the coming months. And yeah, great room by John Hammond. Huge respect for all the work he's done around this vulnerability and putting out information, and obviously this practical resource for us to play around with the vulnerability. I'm interested to see if people want me to do more TryHackMe rooms, or do you want me to keep going with Hack the Box or just general capture the flag stuff. Let me know in the comments below. Thanks for watching.